Good morning, friends. Now we are discussing static forces on horizontal and vertical surfaces submerged inside the liquid. So, to begin with, so we have the definitions of total pressure and center of pressure. So what is total pressure? So if any object is submerged inside the liquid, so the force exerted by the fluid which is in the state of rest on the surface that is submerged inside the liquid, either it is the plane surface or it is having the curved surface. When the fluid comes in contact with that particular surface, so and this total pressure is always acting perpendicular to the surface. Center of pressure, so the point where the total pressure is acting on this surface by the fluid which is in the state of rest is called as center of pressure. So now we will have a horizontal plane surface submerged inside the liquid. So if you take this a body having a regular shape which is submerged horizontally, so that is the area of the surface is parallel to the free surface. So every point of the surface is at the same height from the free surface of the liquid. So that is this area of the body that is submerged inside the liquid is parallel to free surface. So every point here on the surface is at the same distance from the free surface of the liquid. So the pressure intensity on each and every point on this body is same. Let capital A is the total area of the surface, G is the center of gravity of this surface, P is the center of pressure. So P, center of pressure, is the point where the total pressure is acting. So H bar, so that is distance of center of gravity of the area from the free surface. So that is also equal to H. Hc is nothing but distance of center of pressure. So P and G are lying on the same point. So they are at the same distance from the free surface of the liquid. So this H bar and Hc both are same. Now total pressure force acting on the surface F. So it is nothing but total pressure multiplied by area. We know that the pressure is equal to force by area. So force is equal to pressure into area. So total pressure force F is equal to pressure into area. So we know from hydrostatic law that P is equal to rho G H. So P is equal to rho G H. A is area of the body submerged inside the liquid. So now H and H bar both are same. So F is equal to rho G into A into H bar. Now we consider the vertical plane surface submerged inside the liquid. Now the plane that is submerged inside the liquid is perpendicular to this free surface of the liquid. So capital A is the total area of the surface. H bar, so that is distance of CG, that is center of gravity from the free surface of the liquid. So now G and P are two different points. P is center of pressure. Its distance from free surface is HC, from the free surface of the liquid. So to have the total pressure force, we are taking the help of an elementary area. So we'll find out what is the pressure force acting by the surrounding fluid on this elementary area. Integrate the expression to get the total pressure force acting on this entire body submerged inside the liquid by the surrounding area. If you project this body, so that is having the plane, so that is AB here. So P is the point, center of pressure, where the total pressure force F is acting. So consider a strip of thickness DH and width B. So the width of this elementary area is B, and the thickness of the elementary area considered is DH at a depth of H. So that elementary area taken is at a distance of H from the free surface of the liquid. So now pressure intensity on the strip P is equal to rho GH given by hydrostatic law. So area of the strip dA is width of the strip multiplied by thickness of the strip. Width of the strip is B, thickness of the strip is DH. So B into DH. So area of the strip is now dA is equal to B into DH. So total pressure force on the strip dF is equal to pressure multiplied by the area. Pressure is rho GH multiplied by area of the strip. So that is BDH. So total pressure force on the whole body is now given by F, that is obtained by integrating the expression dF. So taking rho and G, which are constants outside the integration, inside the integration I have BH into DH. Now, so it is integration of H into B dH. So B into dH is nothing but my moment of the surface, because moment of the area about the free surface is nothing but here. So it is B into dH. So that is now we know that moment of the force is nothing but force multiplied by the area here. So we are taking here, so this is integration of H into dA. So that is moment of the surface area about the free surface of the liquid. So B into dH is nothing but the area multiplied by the distance. So B into dH is nothing but area multiplied by the distance. So that gives the moment of the surface area about the free surface of the liquid. So now integration of dA is nothing but A, that is the area of the entire body, and integration of H, so that is nothing but H bar, that is distance of center of gravity from the free surface. So my total pressure force is now F is equal to rho G A into H bar. Now position of center of pressure. So now we are taking the equation of total moment of the force, that is the resultant force. So that is F into HC. If you consider this plane, so F, which is at a distance of HC from the free surface. So that is the moment of the resultant force, F into HC. So then we are taking the moment of the force dF about the free surface of the liquids. So that is dF into H. Now we are getting some of the moments of the forces as rho G into integration of dA H square. That is not, we know that integration of this dA H square, that is nothing but moment of inertia. So that is given by IO. So then sum of the moment of the free surface. So that is rho G IO. So equating the sum of the moments and simplifying, we are getting this equation for HC. Thank you.